Hey guys, happy Monday. We're getting towards the end of our unit. So we are today working on final models. Okay, so last Friday, we did a lesson on pressure during the asynchronous work. The first half of this lesson today, we're talking about pressure. We're making sure that we understand how to model it. We understand the different ways conceptually that pressure is measured inside of a system, what makes pressure increase in a system. And that's where we start with our do now right here. So does container A or B show a system that has more pressure? Look at those two models. Which one shows more pressure? So you're going to say container blank shows more pressure because. Then, number two, I want you to look at container C. There's a big question mark. That I want you to imagine and describe a container C that has even more pressure than A or B. It has the most pressure. What would that container be like? Either tell me about the container, tell me about the particles of the container. I'm trying not to give too much away, but think about a situation of container and particle system that has even more pressure. What would that look like? How would that work? Tell me about it here. I'm going to keep going. We're going to have a scientist of the day today. In breakout rooms, we did a little pressure summary. I am going to do some of that for you. If you missed live class right now, I'll do some of that for you. I won't do all of it. Then I will go over the independent work for you, learning target. We're going to do a short reading today. I've actually already posted a video on the slides of me reading that aloud to you in case that's preferable for you. And then you're working on your final popcorn model today. It's Monday for you. So a week and a half ago, we did a popcorn day and we talked about why is popcorn popping. We launched the slow motion popcorn and you guys worked on some models. Then today we've learned so much about particles. We know that hotter particles move faster. We know about state changes. And so we're going to apply that information today and make a new model, a better model, because we as scientists are always just improving our understanding of things and we improve our models to go along with it. Dr. Helen Chu is a Chinese American doctor. She's multilingual, she's bilingual, like most of you. She has a medical degree from Duke, so she is a medical doctor, but she also has a master's in public health from UW. And she is an infectious disease expert and an epidemiologist, and she works at UW. So her whole thing this spring is that normally she studies the flu. So her team had a bunch of samples of people's noses from the flu, and they take samples and they test them to see what kind of flu is around the season, things like that. And then this last spring, at the start of the pandemic, she wanted to test them for COVID to see, do we already have COVID around us? This is early, like January, February. And the government told her not to do it. But she did it anyway, and she started testing for COVID. And because of that, we had information like, yes, people have COVID around here that people didn't know. We thought, oh, it's no big deal. Remember back then, we were like, no big deal, COVID, no problem. That was like back in, again, February, March. But she and her team were some of the first people in the United States that tested samples for COVID. We're like, yes, people have COVID. We need to be paying attention to this. It's going to spread. You could read more about her in this article. I just thought that was very cool. And so let's keep going. Okay, from last Friday. I'm just giving you this definition. You probably learned about it last Friday. I'm going to move my face down here. Air pressure is the force on the walls of a closed container. It's caused, the force is a push. In this case, it's a push. Any force could be a pull as well. But in this case, the things that are pushing are the particles. The particles are colliding with the walls of the container. And that creates force, which, depending on how much area you have, is the pressure. Mathematically, you can calculate pressure by taking the amount of force and dividing by the area it's spread out upon. So if you push a little bit, you push a lot in a little place, that's more force than if you push a little bit over a greater surface. But generally, we're thinking about inside a container, where does the force come from? From the particles colliding with it. And so you can see both in the do now and in this picture, which was a part of your exit ticket from Friday, we can model pressure by looking and using arrows like this. If you were in my class, I would have you be drawing little circles for particles and boop, boop, little arrows like that. but this, we're going to get used to having to do it online like everything else. So we can draw little arrows boop, bouncing off of walls to show pressure. Okay, so during breakout rooms today, people looked and worked on this slide together. If you go to this link, it'll take you back to the FET simulation that you did on Friday that you looked at for the different types of pressure. If you want to remember or you didn't do Friday's work, then you better open this up and go play around with the pressure. In fact, if you don't know anything about pressure, you didn't do the pressure activity, pause this right now. Go back to Google Classroom, look at Friday's pressure lesson, go down to the asynchronous part and do it, please, because this is going to be important. So air pressure in a container is caused by, I actually just said that to you in this video, so either go back or just go back up a couple slides and you can answer this question. I just want you to have to actually write it down so you remember it. Then, using the models that we have from this simulation, I've created 3 containers here for you. I want you to tell me what are the 3 different ways that we learned about of how to increase pressure in a container. You can increase pressure by doing 3 different things. You're going to tell me what they are and you're going to model them. I'm going to do one with you right now. One of them, one that you guys probably know about already, is by, let's see, there are increasing the temperature or average kinetic energy of the particles in the container makes them move faster and collide more often and harder with the container walls. Boom. Okay, so I'm going to model that real quick. I'm going to grab a couple of particles here. I'm going to grab couple of lines. I think these lines don't quite fit these particles. This is a little bit difficult to do. I've done it a bunch of times, so I'm expecting you guys to get used to it. So try to model it with arrows. I'm going to do just extra long arrows. If I'm comparing it to this one, here's like our normal one. How do you increase it? Oh, well, you could have faster particles by increasing their temperature or their kinetic energy. And you can do that or you can model that by showing really fast arrows bouncing off of things. I might just do a double bounce here just to make you guys go, whoa, Mr. Murphy's so good at modeling things with his computer. It's true, I'm like really good at it. It's not true. And real Helen Chu would not be too impressed, I think, maybe, because she does like modeling of epidemics. Anyway, look how these arrows are longer and they're bouncing off of the side and the ceiling here. This is a double bounce, but just looking at the arrows, even if they're broken up into pieces, those arrows are longer than these arrows, which show that they're going faster, which means they're hitting the wall harder. When you go faster, you hit harder. Imagine hitting a building with your car going really fast or really slow. And they're hitting more often because they're moving faster. They're going boom, 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 and bouncing around. Both of those things cause more pressure. Okay, and there's actually 2 more ways to cause more pressure. If you need to remember what they are, open this up and mess around with it and go over it. Okay, but either way, you can do this. And if I run out of arrows, I'm just going to copy and paste the arrows down here. So you can copy and paste, Control C, Control V, paste, boom. So you can always add more and they should be bouncing off of a surface. That's kind of a thing. Anyway, I won't finish this. There are 2 more ways. Go back up here. The important thing is you remember what pressure is caused by and that you're practicing modeling pressure by particles bouncing off of walls. Okay, let's keep going. Today in your asynchronous work, this is your independent work now. Your learning target is I will apply information from a reading to improve your popcorn model. Okay, so this is what our model looks like now. Okay, so the reading is here. You'll find it on Google Classroom. Your job is to find new information in that reading that will help you with the model. We're going to do a stop and think strategy. So that means you're going to read and you're going to stop and you're going to say, did that help me explain why popcorn pops? No. Okay, keep going. And when you find a paragraph that does, you're going to put a star next to it. There's actually a star in the reading. You can just drag it, find the orange star at the top. You can drag it towards the paragraph you think is best, and then underline a few words that help you. If you want me to read to you, done. Click on this, I'll read it to you, no problem. After you read it, Now you're ready to model it. You might need to go back and forth to the reading a couple times and go, wait, what did I read? Oh, yeah. You also might want to look at the popcorn model you did a week and a half ago. That would be here. Here's week 2, lesson 3, popcorn from Thursday, 9/17. Click on it, open it up, scroll down to where you did the model and check it out to be like, oh, you might be impressed. Like, I'm so super smart. You might have been like, oh, that was the first time I modeled anything. This isn't very good. Forget about it. I can do a better one today. The last slide, slide 12, is your model. It's all about why does popcorn pop? Based on the reading, you found some new information. And so the question here now is, what happened to the liquid water particles in the tiny drop of water in the kernel to make it pop? So you're writing one explanation for why it pops here. The sentence starter I'm giving you says, when blank energy, what kind of energy? What should this word be? Was added to the popcorn kernel, the particles started doing what? If you want, I put a little checklist down here. If you kind of go down here on these, there you can drag this up. These like a little notes for you. I want you to think about thermal energy, you adding or removing it. When you're thinking about particles, meaning when you're writing about particles, or maybe when you're drawing particles, can you make sure that you're talking about kinetic energy? You're talking about attraction between the particles. You're talking about their spacing. Talking about what state are they in. Then, if it's easier for you to write, start writing. If it's easier for you to draw, start drawing. I'm going to drag my face up here again. So here, there's liquid particles. When you start, we're modeling the liquid particles inside the kernel. Here's the wall of the kernel. This way you can show pressure by maybe particles bouncing off of this if you want to. You don't have to show pressure if there isn't pressure. It's up to you. After, what state is it in? These particles that we're modeling that start as liquid, what state are they after? That's what I want you to write in here. And then I want you to model them, just like you did before, up on slide 8. Copy and paste these. Use the arrows. These are to help you, these lines that don't have arrows are to help you if you need to like do bounces. You do an arrow and then or a line and then an arrow, right? Just like we did. So that would be like arrow or line rather, and then point the arrow bouncing back, and there you go, that thing's bouncing. I don't know if that's what you want here. I'm just trying to demonstrate why I put lines there for you. You can copy and paste, so if I didn't give you enough, right, if you want 4 particles isn't enough, copy and paste and make a lot more particles, as many as you think you need. This then we will go over tomorrow, and we're going to try to make sure we all understand why popcorn pops. Tomorrow, independent work is your final assessment. So take the time today. Try this. You don't have to be perfect at it yet, but I want you to try to do a really good job in your writing and your modeling. Get good at it so that tomorrow we'll go over the popcorn. We'll do a few practice assessment-like questions. And then when you do your independent work tomorrow, there's your final assessment, which means that when later in the week, we're starting a new unit, looking at what types of molecules there are and what makes molecules different from each other. That's it for me. Get to work on this. This will be due Monday, and then Tuesday we will go over it.